And welcome to Nani Notes. Well, let's look at Venn diagram. In this example, I've got two circles. You could use ellipses, but I'm using circles. And I'm going to say each of these circles is going to depict a set. Normally they're not shaded. I shaded them just to make it more visual. So A and B are sets, and a set is a collection of objects. And those objects are known as elements. Um, let's do this. I'm going to put an element in set A. I'm going to move this out of the way for now. And I'm going to say, using my little notation here, I'm going to say that cat is an element of A. This is the way I would read this. I would say that cat is an element of A. That little symbol right there. And that's of the set A. And then maybe I'll add another element or two. And I don't know, let's say I'm putting dog in there. So now, right now, I see two elements in the set A. I don't really know what the set A means. It could be domesticated animals, for instance, at this point. I could, then maybe I'll put in another one, let's say. Ooh, now it's probably not domesticated animals. I've got giraffes in there. Well, they're not household animals in our country, at least. And now I'm saying, well, let's put something else in there. How about in the other set B? I'm going to put a dragonfly. So set B contains dragonfly. And I'm also going to say that it contains raven. Now, well, set B, could it be birds? Well, no, because dragonflies aren't birds. I'm noticing something, though, that these two sets, as we see them right now, they are disjoint. These two sets have nothing in common. You see, they don't overlap. Now, I'm going to write down here that raven is an element of B, just so we get used to that terminology. Okay, and well, let's make this a little bit more interesting. I'm going to clear this off here. Make sure you know that symbol, that little E-looking symbol. We read that element. So I'm going to clear off this, and I'm going to introduce another element. I'm going to slide this one over so it overlaps. This is why I chose color. I can see the overlap in the green. And I'm going to put another element here. And now you're seeing where this is going. There's a whole lot of possibilities, and I'll let you think about it. But and move this out of the way. Down here, and let's move this out of the way. And we're going to make a list of elements that are in our sets. When I do that, I'm going to write it like this. I'm going to say A. This is going to stand for the set A, in our case, the blue circle. And we're going to use the braces. Be sure that you use these braces, not parentheses, not hard brackets. You're going to use these. These denote sets. Sets, since they have elements, are going to have, well, you're going to put something in place of an element, and you're going to put in a comma. In this particular case, I'm going to say that this set contains the cat. This set contains, well, giraffe. Got a bigger space over here. This set contains the element dog, but this set also contains the bat. There are 4 elements in set A. Okay? And well, let's go to set B. And if I look at set B, I see only 3 elements. I'm going to say that I've got raven, I've got dragonfly, and again, I've got bat. So I have 3 elements in the set B, as denoted with the curvy braces, right? So Let's keep going with this example. I think you've all by now maybe figured it out a little bit, what they have in common. Anybody know what all the elements in B have in common? Let me see, they're not birds. Let me see, they're not, you know. Well, think about it a little bit more. I think you know. And I'm going to change this. I'm going to move this around because the real point of this lesson is to introduce the relationship when I combine set A and set B. Because there's two ways to look at that combination. Ready? Okay, let's clear this off, and I think I've got to just get rid of those. And then I'm going to say union and intersection. Yikes. Well, if you've seen this before, the AUB, this is called the union sign. And it looks like that. So I'm going to say, oops, think U for union. I'm going to put down every single element that's there. It's going to be there. It contains a dog. It contains a dragonfly, or the dragonfly. It contains raven, and it contains bat. That is the combination of both these two sets put together. Now, here's the tricky part. That is true. That is A union B. Looks like a big U. However, I want you to know that this goes with the word or. This is the logical or. And the reason we call it the logical or is because I can look at sets A and B and ask myself a question. What element, or what elements in this case, are either in A or in B? And that's a way of including them all. Students often get confused with this because you're thinking of that A word that we're getting to next. But no, this is the logical or. When you combine, you make a union. It's either in this, it's in set A or it's in set B, so it's all of them. The logical or. By comparison, you all see the green space there. And I'm just going to clean this up a little bit. And this is the logical and. This symbol down here, A, with this horseshoe shape, we read that A intersect B. And that's where the two overlap. That's my green. Blue and yellow overlaps makes green. And we have the single element, the bat. Yeah, I think I screwed up there. Let's leave that up there. Because that green stands for all the elements that are in set A, the blue set, and in the set B. Therefore, the logical and is the intersection of the two sets. You all know what this stands for? Yeah, I think you all got it. We all know that, I don't know, we just used this example in class, and it looks like in the blue, well, maybe that's the set of mammals. And what about B? Well, you could think of animals that fly. And that could be one representation here. So A and B, in this example, the bat. Well, let's work an example that uses numbers. You get something like this on your quizzes, and I have no idea what these numbers mean. Nothing apparent, so we'll just treat them like they're elements. And first off, if you get this on one of those Canvas kind of quizzes, you'll always have to, put the numbers in ascending order or it'll mark you wrong. It's terrible. Oh, the terrible programming. But here we go. Let's, and we're back to a monochromatic setup, just like you would see. So set H is over here. If I want to list the elements of H in ascending order, I'm going to put the 3, and I'm going to follow that with the 6. And you will have to do them in that order if you are asked to do them in that order. There's 1, 2, 3 elements, 3, 6, and 11. that are members or elements of set H. For set K, that's going to be 6, 7, and 21. Now, down here on set W, I've got an 8, and I've got a 19. Now, it's very careful. I ask my students to make their own examples. You got to be careful that you don't do anything silly, like put a 19 here and a 19 there. No, I mean, 19 is one element. This says right here that this W is not in K. As a matter of fact, this set W is disjoint from the other two sets in this picture here. You will get that. For example, the set of irrational numbers would be disjoint from the set of rational numbers, meaning there's no overlap, none at all. They just don't cross paths. Doesn't make sense, does it? So let's do our union. Remember that shape, that U for union, and we're only using H and K for this, and we'll use the intersection. So the union will go from the smallest, that's going to be the 3. Let me see what we got next. Then we're going to take one of those 6s, 3, 6, 7, 11, and finally 21. That will be the union. That's when I combine them. You know, it scares me because combine would lead you so that using the wrong word in formal logic, because in logic, this is the OR function. Remember, this is OR. This says H or K. Every one of those elements is either in H or it is in K. Therefore, it is the union of all elements found in H or K. Now, the intersection, of course, there's only one element there. We'll make that one really simple. And remember, what I'm saying here is that inside the element H intersect K, there is only one element that meets this criteria. The element 6 is in the set H and the set K. Well, no discussion of the Venn diagram would be complete without, well, this most important of Venn diagrams. That is the set of the numbers that we use every single day. Introducing a few new things to our Venn diagram. We already had the disjoint set, last example, but these are proper subsets. That is when a set is entirely inside another. What that means is that an element of this set Z must also be an element of this set Q because it is contained entirely inside. And we'll get some examples of what that means because you probably recognize these letters. They're not random. Oh, no, they mean something very special. Oh, and this rectangle on the outside, we'll call that our sample space this time. And we're going to give that a big letter R. And well, let's get through these. Let's get through what all these letters mean. You probably know this from a previous class. If you don't, well, shame on your other teacher. You should know this stuff. N stands for the set of natural numbers. Now you know that when you see it in writing, you often have these really cool double stripe characters on all these letters, but I built this one. I'm just gonna have to use regular letters here. So just pretend they're the really cool ones you see in the textbook. And we're going to say that the set N of natural numbers. Well, what's the most natural thing to do with numbers? Well, count. These are, of course, known as the counting numbers, 1, 2, 3, etc. Notice they can be listed in set notation, braces, and listing elements, and we're going to put the ... to go into infinity. We can do the same thing for the next set of numbers, which just adds a single element. And yeah, you guessed it, that would be the 0. So we can still mention these numbers like this. So it's it is the natural numbers and includes 0. That's a big deal. Now, let's take the whole numbers and their opposites. That would be a formal definition of the integers. And the integers, they're not abbreviated with I like you'd think. No, they're Z or Z if you're in the rest of the world. And we'll call those the integers. And notice we can still demonstrate them in this listing format. This always gets me. This is infinite, that's infinite, but how can it be the same size? Think about that. So I've got the set Z, the set of all integers, and that's the whole numbers and their opposites. Now is when we can't list them anymore. The rational numbers. We got to define what a rational number is. And I'm going to take a look at this word right here. Rational includes the word ratio. That's a big hint. The ratio of two numbers. And I can't list them anymore. I'm going to write them. Whoa, isn't that cool? All right, that's a cool way to do it, to impress your friends. Q is a set of rational numbers. And if you're thinking Q, no, it's not a conspiracy theory. What you're thinking, Q stands for the word quotient. And quotient is the answer in a division problem. So Q is for quotient, and therefore rational numbers are quotients, or they are the ratio, and that is of two integers. So this is fancy way of, just to look cool. It says it is the set of all numbers A over B such that, that's the vertical bar, such that A comma B, meaning A and B, are elements, remember that from before, elements of Z, meaning, well, they're integers. A and B are integers and B cannot be 0. Remember, division by 0 is not defined. That's the only thing that's illegal. Go to jail. You can't do that. So there you go. It's all numbers A over B such that A and B are elements of Z or Z, and B is not equal to 0. Yikes. There's a lot easier way to say that. You can use, I guess you can use the F word here. Yes, it's a fraction. That is a fraction. So, and then you've got out here P, and I guess a lot of people use P for irrational numbers. And all of these are on this sample space of what we'll call R. That's the real numbers. Now I got a couple specimens here, and I want to put them in their most descriptive location. Now, just to demonstrate what it means, if I take this 11, 11 is certainly a natural number. It's a counting number. 1, 2, 3, 4, 5. I'll hit 11 if I could count that high. And you can see that since it's a natural number, it's inside. It is certainly a whole number. It is an integer. It is an integer. It is a rational number. Now, I always get somebody that asks, says, well, if it's a rational number, isn't it a fraction? The answer is yes, because the number 11 is a fraction. It's 11 over 1. It's 22 over 2. So it still meets the criteria to be called a rational number, and it is real. So the 11 is a natural number. It is a whole number. It is an integer. And natural, whole, integer, getting lost. Rational and real. Okay, let's take number 23. No, yes. It is not a natural number. You do not count to negative 23. It is not a whole number. It starts, its most descriptive quality is that it is an integer. Sometimes some textbooks have the Z plus and Z minus. We're using Z. So, integer, and therefore, if it's an integer, it's rational. Because, again, I could represent that as negative 23 over 1, and it's real. So it is a member of those three sets. 9/16, you saw this coming because you got your ASE tool set out, and you can see that is a rational number. Well, it's got 9 over 16. It just makes sense. I mean, just look at that. Does that meet the definition? Yeah, betcha. A over B such that A, 9, and B, 16, are elements of Z. In other words, it's a fraction. A fraction is a ratio of two integers. So it's rational and it is real. Now, we always threw this one out there. Gosh, I should come up with it. Maybe I should use phi or something else. But you guys all know pi. Pi is your good friend. Well, your good friend there, the ratio of a circle circumference to its diameter. And that, in his example, that is a classic example of an irrational number, which, of course, then is also real. And there you have it. A few examples of the sets of numbers. I hope this is helpful. And if you're in my class, I guess it's going to be really helpful when it comes time for that Canvas quiz. So that's all for 90 Notes.